right, here's a polar area, part 3 and third example. I've graphed two graphs here. I got r equals 4 plus 4 cosine, that's in green, so I underline it in green. So that's the big one there. And then r equals 2 just means radius is 2, so it was just 2. I made every circle by 2 because this one gets all the way out to 8. I don't want to do 8 circles, so 2, 4, 6, and 8 is each circle. That's the scale. And so you can see a little better. So I did this graph in your notes so you can see it. All right, they ask us to find the region, area of region R and the area of region S. Okay, so we're going to find the area of region R first. Now, the key to doing the regions is you got to find out when they intersect each other. So to find out where they meet, I'm telling you, here's the meetings at 2 pi over 3 and 4 pi over 3. A lot of times the AP test will have those lines drawn and it'll tell you they meet here. It saves you a good little time. But if you want to know when two things meet, don't we set them equal to each other? So we set I set them equal to each other and I solve. Subtract 4, divide by the other 4, I get negative a half. Well, cosine equals a half at 60-degree reference angles. But what's cosine negative? Well, he's negative in 2 and 3. So 60 degrees up there is 120 and 240. Because cosine equals a half at 60s, the negative 60s are 120 and 240, so that's 2 pi over 3 and 4 pi over 3. And so we could do that ourselves, but if they tell us, more power to us. All right, here's the hard part. You got to figure out, we're going to do region R first. So area, which graph touches region R? Is it the red graph, green graph, both? In this case, clearly both. If you look at R, it's surrounded by some red and some green. So we're going to have to do the integral in phases. So to start off, here's 0 degrees. Right here's 0. So if you start at 0, you're touching the red. So to find this area, if I start at 0, I'm touching the red, so it's that equation. So remember, it's our function squared. Okay? 0 to where? Well, if I were to shoot the sprinkler here, I hit red till I hit this value where they meet. So if I go 0 to 2 pi over 3, I'm going to find the area of that little section there. All right? But now I can switch over. I can switch over because if I continue on the red one, I'm going to be finding the area of this section over here. I don't want that section over there. So I want to start in the sprinkler. I want the sprinkler, once it hits the intersection, to now start hugging the green. So from 2 pi over 3 till here, 4 pi over 3, I have that function. And so that will get this region and this region. I'm almost done. If I continue on the green, I'm going to go out here. I don't want out there. That's not region R. So now I got to switch back to the red. I'll put it right below it. I got to go the red equation from that point 4 pi over 3 to the end at 2 pi. And that would be the 3 different regions I can do if I could do one at a time. There's a lot of shortcuts we could take. I just wanted to kind of go through, here's what you would do if you just worked your way around it. So you start here and go, all right, from 0 to here, I'm on red. And then if I were to spin, I'd be on green from 2 pi over 3 to 4 pi over 3. Then I'd switch back to red to the end. And if I do those integrals, the sprinkler only goes to what equation you're doing. All right, so the final answer for all this, 9.262. That way you can check and see if that's what you get. Okay, good practice. All right, what's a faster way I could have done this? Well, I could have gone from here to here, like we did, and doubled it. If I double that region, then I get that one too, because that's the same region just down below. If you look at it, looks symmetric. So if I could have just said, I'm going to do this one by 2, and I don't have to do this one. and then kept this, and that would give me 9.262. But could I have only done half of this one and doubled it instead? It's really not any faster, but what if I did from 2 pi over 3 to pi right here, stopped at pi, and doubled that region? That would also be 9.262. So what that one would look like is I go here, get all that, and then do the green one for just to there, and I got half of my region, double that, and I got the full region. All right? Well, how to do S? All right, so that's region R, number of ways to do it. So region S, well, if I start at 0, I'm way over here. I'm not in region S, but I have region R, which is 9.262. That's all that part. If I find the area of the whole circle and subtract off R, I get S. All right, so that might be the best way to do that one. So area of region S is, I mean, you could area the full circle. It's a circle. Area of a circle is pi r squared. Okay, so 4 pi. Or, this would work, 1/2 2 squared from 0 to 2 pi. I'll do it by hand in just a second so you guys can see it's a formula you learned in junior high. If I take the integral of that from 0 to 2 pi, it gets that whole area. And if I subtract off, you know, region, do a capital R there, region R, if I take all this area and subtract off that, then I'll get my region S. So a lot of times you'll want to find one area and subtract another. So far, that should be 3.305 for the final answer. Let me erase all that. So that's one way you can find region S. You can do it real complicated. Do one minus the other. It gets really complicated, so that's probably the best way to do in region S. All right, I showed you, I proved this to you. Well, let's see, this is 2 squared is 4. Integral of 4 is 4 theta. From 0 to 2 pi, and don't forget I got the half. If I plug in 2 pi here, I get 4 pi minus 0, 4 pi. As we said, the area of a circle is pi r squared, 4 pi. So we just verified that. So 4 pi and then minus region R, which would be that. Okay? So sometimes you have to find the area between two figures. That would be what it would look like. But the key is just think of it as a sprinkler and you're spinning, and start at 0 or wherever you want to start, but usually we start at 0 until, you know, if it's covering our region. All right. Now, if I want to find way out here, I can find all the area of the whole green. Green doesn't have that loop like the lime cone. This is called a cardioid. This is actually the heart-shaped one. If you just look at that graph, it's better to see it on your picture here without, on your notes without all my drawings on it. But that's a cardioid. So to find the area of the cardioid, you could just go 0 to 2 pi and then subtract off that region R, and you'll get the outer region in there if you wanted to. All right. So there's polar area, and watch all 3 videos and you'll get a, be able to do all the problems.